Alright, welcome back. We're going to be finishing up the Steganography project. So far we've written our getDataLocations method, our decode message method, and we've also got our exceptions. The last thing we need to do is encode a message. And luckily that's not actually that different from decoding a message, so we'll be referencing a lot of this logic for our encode message method. So if we go back over to our page, we can see what the outline of our encode message method is supposed to look like. Again, it's static, it doesn't return anything, but it takes an input file, an output file, and the message to encode, and it throws a general exception rather than a secret message exception. So let's write that out. File string message, and finally we throw an exception. Alright, so now we've got our throws exception. So now that we've got our outline, what the first thing we need to do is go back. We should go back and read through what it does first. It should make a copy of input file and save it to output file. So this means that we're not going to be writing to input file. We need to copy input file to output file and then exclusively write to output file. And luckily there's a pretty easy way to do that. It's using the files class. So I'll just write files.copy, and then you need to do input file and output file. And this, there's one other thing that should be in here. These are files, so we need to turn them into their input and output streams. And so what we can do is or not their input and output streams, we need to change them to their paths. So we just add .toPath to each of these. You may have seen, there we go, path source, path target. The last thing we need is what are called copy options. And this is actually important because we want to overwrite whatever is at output file. So we can use, let's see if it'll give me a prompt for it. Whoops. Alright, so it's not going to give me a prompt for it, and I'm not going to bother with it. It's not that critical, it's just something that you can add later if you want. But remember, we'd want to put in copy options, because that will allow us to overwrite whatever output file is here. So the next thing that we want to do is we want to open up our random access file so that we can start browsing through the file. That's going to be pretty similar to what we did up here. And of course we're going to need to try in case input file doesn't exist for some reason, or output file doesn't exist for some reason. And the other change we're going to be making is instead of just, output file. The other change we're going to be making is instead of just an R for read, we are going to want to read and write from this file. So we just need to write WR, and that will allow us to read and write. And then if an exception is thrown here, if we catch an exception here, we can just throw that exception, because we throw all kinds of exceptions. And it's also telling us that RAM is never closed. So we're going to sort of copy the structure here. We're going to have two tries, and we're going to put the other one down here and close RAM inside of this try block, because it might throw an IO exception. And we can also just throw that exception. All right. So the first step to encoding a message is, well, let's think a little bit about it. So we can go back over to our schema or our graph here, and we can just imagine that instead of these being specifically in here, it's basically just blank after the header. What we need to do is we need to create each of these inside of the file, and random access file has read methods, but it also has write methods, and so we don't need to really do anything different. We can just write integers and write characters into the file as long as we seek them to the right place. So the first thing that we need to do, as we did with the with decoding a message, is we need to figure out what we're going to do about the message length. So to find the message length, we can just take the string message and take its length and that will be our message length. So that's our message length. It was pretty easy to get. And the first thing that we're going to do is we're going to encode it at the 50th byte. So I'm going to seek to that 50th byte, and we're going to write an integer there, write int, and that will be our message length. So the next thing we're going to want to do is we're going to want to do a similar thing to what we did in decode, which is we're going to want to loop through all of the characters in our message, and instead of finding them or reading them out of the file and finding their next position, we're going to want to write them into the file and write their next position, and then seek to that next position and write the next character. So it's basically just this, but a little bit more backwards. And so we can do that similarly with a for loop, just like the one that we've got here. Now the only other thing is we need to before we even do any of this, we need to find the locations of where we're going to be writing the characters, and luckily we've already got a method for that, get data locations. So let's go ahead and get data locations, character locations equals get data locations. And then get data locations requires a start, a stop, and a number of locations. So the start is going to be 54 because that's the byte after the length of our message, and then the stop is going to be actually the length of our file. So I'm forgetting how to do that. I think I can just do output file. Oh no, how we get the length of the file is we can actually use random access file to do that. So int file length is random access file, or ram.get, where is it? It's one of these skip bytes dot length. Okay, so yeah, it's just RAM or our random access file dot length, and this is the length of the file in bytes. This returns a long, so what we can do is we can just cast it, or if you are really scared, you can write a method that will safely cast it, because longs are obviously longer than integers. So the next thing we need to do is pass in that file length, and our number of locations is just our message length, so we can pass message length into here. So this should return an array of where all of the characters should go in our array, and if it does throw a not enough space exception, we'll just catch it down here. I'll get rid of IO exception and just catch exception. There we go. So now that should just throw whatever exception comes out of character get data locations. Alright, so now that we've got all of our character locations, we've written the length of the message into the file. Now we just need to loop through all those character locations and write our characters into a file. So the first thing I'm going to do is I'm going to create a character array out of my message length, or out of our message, character message array to char array. So basically we're just converting our string into a character array, and you'll see this is really useful in a second. When we write our for loop, we can just reference these things both with our index rather than having to use index or character at index or whatever it's called. Message length and ++. Alright, so now we've got our message in an array of characters. We've got where all of the characters need to be. We've written the length of our message into our file. The next thing we need to do is use sort of a similar method here, but sort of backwards. We need to write our character in, write our length in, and then go to our next, the position of where our next character is going to be. So similarly, I'm going to use a long to hold the cursor's position. And we're going to just get the file pointer here, just like we did up here, to keep track of where our file pointer is. And then we're going to, the first thing we're going to do in our for loop is we're going to write our character in, because that's how it works. We have a character and then we have the index of the character. So wherever the cursor is, we're going to want to seek to that position, cursor position. In our base case, it'll be 54, so we'll be writing this character, but for any other place, we'll be writing it to whatever the cursor's position is, which will come out of this character locations array. So let's seek to that position. Then we will use our RAM to write a character, and we need our message array, and we can just reference the character at this position with our index, and then we can ram.write int, and we'll do the same for our character locations. So now basically we've seeked to our cursor position. So in our base case it'll be 54. We'll write our character, we'll write our first 2 bytes, and then it will have seeked after those 2 bytes, so we can then write our integer in. And then all we need to do is set our cursor position to the next place where our integer is. Now, if we think about it, this is actually going to be a problem, because this isn't the position of our next location, this is at the position of our current location. So this is just going to write 54 and we're going to be in a loop. What we need to do is we need to write the location of the next character. But see, this is also going to be a problem. We're going to get an index out of bounds exception, because eventually I will be the length of the character locations, and so this will throw an error. So what we're going to do is we're going to hold, we're going to use an integer to hold where our next character is going to be. And we're going to default it to 0. We're not going to set it to character locations right now, we're going to set it to 0, because if we go back and read through this some more, you can say that it says that the int at the end of the message should be 0. So we can, if we just use this as our base case, then we can write an if that will properly assign character location. Otherwise, it'll just be 0, and then we'll know that we're at the end of the message. So we'll say if I is greater than, what is it? If I is less than message length, I plus 1 is greater than message length, or less than message length, then we can set next character location to the character location in the array. Character locations. There we go. And then we'll just write that into where it is. Next character location. So now we've seeked to our cursor position. We've written the character there. We've checked to make sure that we're not at the end of the message. And if we are, we write a 0. But if we're not, we write the position of the next character. And finally, we need to make our next cursor this next character location. So we can easily do that just setting the cursor position to next character location. And as it loops through, cursor position will get set to the next character location. So when we come back up here, it will seek to that position, which is the next character location, and it will write them, and it will continue for the rest of the message. Now, the way that we can test this is, of course, we can write it into a new file, and we can try going through byte by byte to find it, or we can use our decode message and see if the string that we passed it is the same as the string that we encoded it with. So this is a void method. We're not going to do anything here. We're just going to assume that we're done. But what we can do is in driver we can write a method that will check it, or of course we can write it directly into encode message. But we're going to write it out here so that we can return true or false and see that it truly is the message that we put it in. So I'm actually going to write a new method for this, static boolean encoded, and of course it'll take the same parameters as encode message. It'll just return a boolean so that we can tell if it was encoded correctly. So the first thing we're going to do is we're going to say, we're going to encode, and you got that. And throws exception. Actually, we don't want it to throw an exception. If it does throw an exception, we want to return false. So let's try this and catch any exception. And the other thing the next thing we need to do is to make sure that this was encoded correctly. We can say return steganography.decodeMessage, and then instead of passing this input file, we pass it output file to check the file that we just created, and then we want to make sure that that's equal to the message that was passed to encode. So this should return the message that it gets out, and this should return the message, and this is the message that we put in. So this will see if they're the same, if it correctly read the message out of the file. And it looks like we've got another secret message exception. So we're going to put that up here, and we can just catch all the exceptions. I am going to print the message because I want to make sure that we can tell what's going on, but this should show us correctly if encoded works correctly. So what we're going to do is, instead of using this, we're going to write a message to encode. We're going to then try and encode these things and see if it works. So we're going to hold encoded in this variable. And here we can just use new file and pass in the names of our files. And then message. And then we want to print and correctly encoded. All right, so what are we going to put in here? Well, we need a file that is sort of blank to output to, and then we need a name for a file that would be, that we can output to. So this one is called encoded1, so I'm going to call my output file encoded2. And I actually need to use one of the files that was given here as a blank file. This is definitely not a secret message. And we should just be able to save that, and then I can go back to Eclipse and definitely not a secret message, throw in here, copy it out. So now that we've got definitely not a secret message, I'm just going to write the message name, or the file name in here, definitely not a secret message.wav. All right, so now basically what we're doing is we've created a message that we want to encode. We've written a method that will check if this message is correctly encoded. It will pass the files to EncodeMessage and the message, and then it will return if the message that we passed is equal to what we decoded from our message, or from our file. And if it doesn't, then it will write what the problem was, and it will return that it wasn't correctly encoded. So I'll write just to make sure we can understand. All right, so now we'll write correctly encoded true or false depending on whether it worked or not. So let's see if it works. All right, so illegal mode WR must be R, RW, RWS, or RWD. All right, so looks like that's coming from right here. It's not RW or WR, it's RW. So we just switch those around, and then we'll play it again. And it says it was not correctly encoded. So this is the message we're getting out, encoded2.wav. I don't know why I keep saying wav. Let's see. So I'm guessing this was this failed somehow. It didn't actually copy it, and so this is where copy options is going to come in. I'm not quite sure how exactly to do copy options, so let's just go over here and make sure we get the right import. So basically, copy options is just a way for us to see that we're copying the class correctly. I'll put that there, and then we need to write replace existing here. And you're not working for some reason. No, I'm not going to delete this stuff. I'm going to do what I want. Maybe I spelled it wrong. I don't know. Oh, I need a comma. That's why. All right. Okay, so that should work. Okay, cool. So basically, this just tells file.copy to write and encode whatever the whatever is there. It doesn't matter what it is. It's always going to replace it, and it's always going to create a new file. So let's try it now. All right, so it says it's not correctly encoded, but it's not even passing us a message. So let's move away from our use of encoded, and let's just see what the decoded, what it gets as a decoded message. So it has run encode message a couple times, so we do have encoded 2 here. If we refresh our view, you can see encoded 2 was created. So let's move away from this, and let's just try and print out the message that we got back. So, and we can write Steganography, and then we'll just do a file. All right, so this is going to throw a secret message exception. And we just want to print that too. And we'll see whatever's going on. All right, so this is just going to print the message that we get from our decode message that's coming out of encoded 2. So let's see what happens. This is a seeker, and we get a bunch of periods. Okay, so for some reason it's failing right there and putting in a bunch of periods. That's interesting. Let's see what might be happening. 54, file length, message length. All right, so for some reason it's getting about halfway through the string. This is a secret message, as the rest of the characters. So let's see why it's only getting through half of the string. Let's actually go and I don't want to try and find the index of this character. So we're just going to add some print statements to here and see if we can see why the character is always a bunch of periods. So first I'm going to make sure that our message is correctly being converted to a character array. And we're going to just use system.out.println. And we'll see what that does. I don't think that will actually print out everything. No. Also because we need to run encode message. So let's do this too. I'll probably be spelling that wrong a few times. And message. All right. Yeah, whatever. All right, so now that encoded actually does get run. So it looks like the character array is correctly being converted. Let's print out the character every time we loop through it and see that it's correctly being accessed. So it looks like, yeah, that's being correctly accessed. So why is it writing a bunch of periods? Interesting. Next character location is 1 if I plus 1 is less than the message length. Yeah. Oh, if I plus I. Whoops. All right, that should be I plus 1, not I plus I. There you go. Little typo makes a big difference. So let's go back and see. This is a secret message. So now it should be working. And we can check our Boolean, and it still says we're not correctly encoded. Well, it was printing, so I assume, oh, it's because we're using double equals. That's why. All right, dot equals. Yeah, so double equals doesn't work properly with strings, so there we go. Now it's correctly encoded. All right, so there is you could write like a much better front end to handle encoding and decoding secret messages. Something that I did was I also improved the encode message where in the get data locations where instead of evenly spacing them, you randomly space them, and there's a way to a couple of sort of algorithms and math that you can do to get random locations that don't collide with each other. But this is basically what you need to do for the Steganography project, and I hope that this video has been helpful for you. And yeah, Steganography is fun, so happy to show you all how to do it. Have a nice day.